Hey there, gang. So far in this unit, we've primarily been concerned with how to simplify algebraic expressions. We've looked at how to combine like terms and how to use the distributive property. And we'll continue to practice simplifying algebraic expressions, but the rest of the videos we look at are going to be focused specifically on what to do with the exponents and some specific exponent rules. So you should not forget what you've already learned prior to this video here, but now we'll be looking at some special cases involving exponents. There'll be 5 rules in all that we're looking at over the next few videos, and you're going to look at the first 2 today. What to do when you have 0 as an exponent, and what to do when you have negative exponents. So we'll start with our first rule, 0 as an exponent. Anytime you have a number or a variable base taken to a power of 0, you get an answer of 1. So our rule is for every non-zero number, a to the 0 power is 1. So for example, 5 to the 0 power is equal to 1. Negative 2 to the 0 power is equal to 1. 1/3 to the 0 power is equal to 1. X to the 0 power is equal to 1. It's a pretty simple rule to remember. We'll explain in class why that's the case, but for right now, just for this video, just accept it for what it is. Anything to the 0 power is equal to 1. So that's rule number 1. Rule number 2, which is going to take a little bit more practice, is what to do when you have a negative exponent. And so this rule says that for every non-zero number a to a negative power, or in this case, a to the negative n power, is equal to the reciprocal of a to the positive n power. And we write that as 1 over a to the n. So for example, if I had 6 to the negative 2 power, I would rewrite that as the reciprocal of 6 squared. So that would be 1 over 6 squared, which would become 1/36. Negative 8 to the negative 1 power, I would write as 1 over negative 8 to the positive 1 power, which would just be 1 over negative 8, or negative 1/8. X to the negative 5th power, I would rewrite as 1 over x to the 5th. So that rule takes a little bit more practice, but we'll be combining that rule, negative exponents, with the rule number 1, 0 as an exponent, to learn how to simplify expressions that contain either 0 or negative exponents. And so that's what the rest of these examples are going to help you to practice. So let's look at number 1, 2 to the negative 4th. So first of all, let's look at the directions actually. Simplify each expression. Anytime you have an expression with 0 as an exponent or negative exponents, you need to use these rules to rewrite those expressions. Okay, so number 1, we have a negative exponent there. So our rule says that when we have a negative exponent, we rewrite this expression as the reciprocal of the positive power. And so that means we do this as 1 over 2 to the positive 4. Okay, so now our exponent becomes positive, and now I can simplify the denominator of that fraction. 2 to the 4th power is 16, and so my answer is 1 over 16. Number 2, I have a negative number, negative 7, that I'm taking to the 0 power, and we learned that anything to the 0 power is equal to 1. So my answer to number 2 is simply 1. Number 3, 8 to the negative 2 power. I would rewrite this as 1 over 8 squared. And I know that 8 squared is 64, so this becomes 1 over 64. Number 4, 5 to the negative 3rd power. I have a negative exponent, so I will rewrite this as 1 over 5 to the positive third power. 5 to the third power, 5 times 5 times 5 is 125. So this becomes 1 over 125. Number 5, 9 to the negative first. I'm going to rewrite this as 1 over 9 to the positive first power. And that just becomes 1/9. Number 6, 4 to the negative fourth power. I rewrite this as 1 over 4 to the positive fourth power. And 4 to the fourth power, remember, is 4 times 4 times 4 times 4. You can use a calculator for that if you need to. Let's go ahead and go off to the side and just take a look at that. That would be 16 times 16, and 16 times 16 is 256. So this simplifies to 1 over 256. Okay, so now we'll get a little bit more challenging. I want you to look at number 7 and number 8 right now. Look at number 7 and number 8, and notice what the difference between those two problems is. The difference is one has parentheses and one doesn't, and we've talked about that a little bit before when dealing with exponents. So for number 7, because we have parentheses around the negative 3, we're going to rewrite this as 1 over negative 3, still in parentheses, to the positive 2 power. Again, that's what this negative exponent means. It means do the reciprocal. And negative 3 times negative 3, that's what negative 3 squared means, is equal to positive 9. So I'm going to get an answer of 1/9 for problem 7. Problem 8 does not have parentheses around the negative 3. So you have to remember that when there are no parentheses around your base, your answer will always be a negative. Okay, our answer here is going to be negative. What I'm going to do is I'm going to treat this as a negative 1 times 3 to the negative second power. Okay, that's what that means when you don't see parentheses. And so if we remember our order of operations, we do the exponent part before we multiply. So I need to now do 3 to the negative second power, and that would be 1 over 3 to the positive second. And then I'm just going to bring down this negative 1 and the multiplication. So now I have negative 1 times 1/9. And so here you get an answer of negative 1/9. So it's important for you to see the difference because that will come up on your problem sets and on tests and quizzes. Okay, number 7 you get positive 1/9, number 8 you get negative 1/9. In number 9, this time we have 2 powers that we're multiplying together, 3 to the fourth times 9 to the negative second. You're going to treat this as an order of operations problem. So you know you simplify exponents before anything else. So we have 2 exponents in this case. 3 to the fourth power is going to give us 81. And then 9 to the negative second power, we would rewrite that first of all as 1 over 9 squared. And so now I can bring down my 81, and this is going to be 81 times 1 over 9 squared is 81. So now we have the multiplication problem 81 times 1 over 81. And we know how to multiply fractions like this. This would give us 81 over 81. And so we end up getting an answer of simply 1. Number 10, this time I'm multiplying 3 powers together. So I'm going to simplify the exponents first individually. I have 8 to the negative third. I need to rewrite that as 1 over 8 to the positive third power. I have 10 squared. That gets rewritten as 100. And I can put that over 1 if I'd like to. And then 4 to the 0 power, remember anything to the 0 power is 1, so that just gets rewritten as 1. So now I have the problem 1 over 8 to the third power. That would be 8 times 8 times 8, or 512. So this is 1 over 512 times 100. So I end up getting the fraction 100 over 512. And now I need to reduce. I can divide both 100 and 512 by 4. And that gives me 25 over 128. All right, on the backside, we're throwing some variables into the mix now. Number 11, x to the negative 9th. Negative exponent, I'm going to use my second rule and rewrite this as 1 over x to the positive 9. And that's all I can do when my base is a variable, is just rewrite it using the rule. Same thing for number 12. A to the negative 4th, that would become 1 over a to the positive 4th power. All right, let's look at 13. So we have a numerical base 3, and then we have two variables, an a and a b to the negative second. You have to remember that the exponent negative 2 only applies to the b here. The 3 and the a both have exponents of positive 1. So it might help if I rewrite this as 3 to the first times a to the first times b to the negative second, and just include those multiplication signs. So you can see that we're going to treat the b power separately than the 3 and the a. So I need to rewrite this power, b to the negative second, with a positive exponent. So that would be 1 over b squared. The 3 and the a I'm going to leave alone. I can write them as 3 over 1 times a over 1. If I would like to. And so that helps me see how this is all going to go back together. So I'm multiplying three fractions, 3 over 1 times a over 1 times 1 over b squared. And remember, with fractions, when multiplying, you multiply all of the numerators separately and then all of the denominators separately. So my numerators are 3a and 1. 3 times a times 1 is just 3a. My denominators, it's 1 times b squared, so this just becomes b squared. And that would be my answer, 3a over b squared. 14, I'm going to do the same thing. I'm going to treat each of these powers separately. So my first power, r to the negative 6th, I have to rewrite that because it has a negative exponent. This becomes 1 over r to the positive 6th. I also have to rewrite s to the 0 because it's a 0 exponent. That becomes just 1. I could also write that as 1 over 1 to make it a fraction. T to the 11th, I don't need to rewrite it, but since we're working with fractions, I can put it over 1 as well. So now, again, I'm going to multiply my numerators together. My numerators are 1 times t to the 11th, so I get t to the 11th. In my numerator. In my denominator, I have r to the 6th times 1, and so my denominator is r to the 6th, and then this would be my answer, t to the 11th over r to the 6th. All right, number 15. For this problem, we have a negative exponent in the denominator, so I'm going to show you what to do when you see a problem like this. So remember, a fraction bar means to divide. So really, this problem is saying take 1 and divide it by x to the negative third. So x to the negative third, I can rewrite that as 1 over x to the positive third power using my negative exponent rule. So now I have 1 divided by 1 over x to the third. Well, you know how to divide by fractions, right? You multiply by the reciprocal. So I can change flip for this problem and make this 1 times, and then if I flip this fraction, I end up getting x to the third over 1. So what's 1 times x to the third over 1? It's just x to the third. So that would be my answer. Now let me show you a really quick way of getting that answer without showing all of this work, even though this is what we're really doing. Okay, so let's look at the problem a little bit differently. When you have a fraction with a negative exponent inside of that fraction, the entire power, so the base and the exponent, is always going to move to the opposite part of the fraction. So if the negative exponent is in the numerator, the power will go to the denominator, or in this case, the power from the denominator goes to the numerator. As soon as it crosses that fraction bar line, the exponent becomes positive. So now this becomes 1 times x to the positive third power, and the only thing left in the denominator now is simply a 1. So you get x to the third power. You're going to see another example of that here shortly in number 17, so we'll come back to that again. Number 16, let's take a look at this one. So I have a negative 8, which is, remember, to the first power. So I'm just going to rewrite that as negative 8 to the first power. I don't need to do anything to that right now. Next, I have an a to the negative third. I need to rewrite that as 1 over a to the positive third power. Next, I'm multiplying that times b squared, so I can leave that alone. And then finally, I have a c to the negative second power. I also need to rewrite that as 1 over c squared. So let's throw in some denominators of 1 here and here. And so now I can multiply my numerator straight across. Negative 8 to the first, that's just negative 8 times 1 times b squared times 1. I'm going to get a negative 8b squared in my numerator. In my denominator, I have an a cubed times a c squared. And that would be your answer. All right, number 17. Again, you see I have negative exponents in the numerator and the denominator. So again, we'll practice that trick we saw in number 15. But the first thing I want you to see is you have numerical bases in both the numerator and the denominator, a 6 in the numerator and a 2 in the denominator. What do you do in cases like this? Well, you reduce. Okay, 6 divided by 2 is 3, and 2 divided by 2 is 1. So we're going to reduce those two numbers here, and then I'll rewrite my new fraction with a 3 in the numerator and a 1 in the denominator. Now let's look at your negative exponents. You have an m to the negative 8th here in the numerator, and you have a p to the negative 1st in the denominator. That power with m is going to come to the denominator because of the negative exponent, and that power with p is going to go to the numerator because of the negative exponent. The n stays in the numerator. Okay, it has a positive exponent, so it doesn't need to go anywhere. So I'm just going to rewrite the n now. It was already in the numerator. It will stay there. The p to the negative first, remember, it went to the numerator, and now it's a p to the positive first power. The m to the negative 8th went to the denominator, and now it's an m to the positive 8 power. So simplifying this down, we end up with the fraction 3 np all over m to the 8th. Remember, in our answers, we should never have any negative or zero exponents, and so that's how we simplify something like number 17. All right, last example, number 18. I have 3 to the negative third power. I need to rewrite that as 1 over 3 to the positive third. Same thing with m to the negative fourth. That becomes 1 over m to the positive fourth. N to the fifth I can leave alone. I'll just write it over 1. So this becomes the fraction n to the fifth all over 3 to the third is 27. So it would be 27 m to the fourth. All right, so if you have any questions over this video, make sure those are written down so that you can ask those the next time I see you. Until then, have a nice day. You're all wonderful people. Take care.